Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. And for reflection of light, what the definition of reflection of light? Anyone remember? What the definition we use for reflection of light? Yes, anyone? Light travels in a straight path is known as the reflection of light. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Always remember, whenever it asks in a paper to write down the definition of any word, it always requires a textual word. Whatever is given in the textbook, that you have to write down in the definition of that word. It asks about the refraction of light. So what you are going to write? What is given here in the textbook? Light changes its direction when going from one transparent medium to another transparent medium. If you written your own word in the definition part, you never get a marks, or they reduce your some marks in that. Always remember it. And try to by heart from the textbook. Here you can see in the screen refraction of light passing through a glass slab. This experiment you did. Most of the in science practical, it asks this definition, this experiment. In science one, most of the time it asks in a paper also. So what you have to do in that? Keep a glass slab on a blank paper and draw its outline. PQR. Draw an inclined straight line on the side of PQ. Here, this side in PQ, you have to draw an inclined straight line, and so that it intersect PQ at N. Here you can see, places two pins vertically at 2 point A and B at along the line. Look at the pin A and B from the opposite side of the slab and place a pin C and D vertically so that the image of A and B this side here. Here it is a glass slab. First you have to draw this outline. Then draw one straight line and one inclined straight line which intersect a PQ at N. Now from this glass slab, this side, you press the pin and give it a name. It is A and B. Then look at the pin A and B from other side of the glass slab, from the opposite side of the glass slab, and press the pin where you get this line, in that glass slab image. There you have to press the pin. So what happened? You get the vertically, so image of A and B are in line with C and D. You can't get this straight line like this. You get this way and little bit slide on other side of the glass slab. Now remove the chip and pin and draw a straight line going through the point C and D so that it intersects the SR at M and join M and N. Observe the incident ray AN and emergent ray MT. Here you can see this is a I. I stand for angle of refraction. That is angle of incidence. And R it is for angle of reflection, or you can say refraction. I is equals to R. Always it form equal angle. Suppose this side you put that pin is around 45 degree. The other side also you get the, when you press the pin it is around 45 degrees Celsius. So like that you can use this experiment. So always angle of incident is equals to angle of refraction. I equals to R. That you have to remember. What you observe in that, the value of I is always equals to the value of R. Now law of refraction. Law of refraction, incident ray and refracted ray at the point of incidence N are the opposite side of the normal to the surface of the slab at the point, that is CD. And three incident ray, refracted ray and the normal are in the same plane. As I say, this one angle of incidence, angle of refraction and angle of incident normal. This one, it's a normal. This one angle of incidence, that is I, angle of refraction it is R, and this angle it is the normal angle which is intersect at PQ. So your first law of refraction is incident ray and refracted ray at the point of incidence N are the opposite side of normal to the surface of the slab at the point, that is CD at 3. Incident ray, refracted ray and normal ray are in the same plane. This you can write down sometime in your own word. The 3 incident ray, refracted ray and the normal ray are in the same plane. That is your first law. Second law, from a given pair of media, here air and glass, the ratio of sin I to sin R is a constant. Here I is the angle of incidence and R is the angle of refraction. It is constant. Constant it means equal, because the air and glass, the ratio of sin I and sin R both are constant. That is the second law of refraction. Then refractive index. Refractive index depend on the velocity of light in the medium. The change in the direction of light ray while entering the different media in a different, it is related to refractive index of the medium. The value of refractive index is different from the different media and also for light of different color for the same medium. The refractive index of some substance with respect to vacuum are given in the table. The refractive index of medium with respect to vacuum is called the absolute refractive index. That is sin I upon sin R equals to constant. That equals to n. N is called the refractive index of the second medium with respect to the first medium. The second law is also called the Snell's law. A ray incident along the normal I equals to 0 and goes forward to the same direction R equals to 0. Here in the table you can see the refractive index of the different substance are different. Now twinkling of star. The local atmospheric condition affect the refraction of light to some extent in both the example above. The air near the hot road or desert surface, the near the holy flame is hot and hence rarer than the air above it. The refractive index of air keeps increasing as we go to increasing height. In first case, above the direction of light rays coming from distance and keep changing according to the law of refraction. The light ray coming from a distant object appear to be coming from the image of the object inside the ground. As shown in a figure 6.5, is called mirage. Some distant object appear to be coming from the image of the object inside the ground is called mirage. In the second example, the direction of light rays coming from the object beyond the holy fire changes due to changing refractive index above the fire, thus the object appear to be moving. It is clear? Mirage. When the light rays coming from a distant object appear to be coming from the image of that object inside the ground. It is called the mirage. It's clear?
Yes, sir.
Effect of atmospheric condition on the refraction of light can be seen in the twinkling of the star. Stars are self-luminous and can be seen at night in the absence of sunlight. They appear to be point sources because of their being at very as the density of the air increases with the lowering height above the surface of the earth, the refractive index also increases. Starlight coming toward us travel from rare medium to denser medium and constantly bend towards the normal. This makes the star appear to be higher in the sky as compared to its actual position as shown in a figure. They are in compared of their actual position, we always seen that the from rare medium to denser medium it constantly bending towards the normal medium. Suppose in night, as you are moving or you are walking, and you can watch in the sky, so you feel that the stars are moving with you. Correct, no?
Yes, sir.
That is the twinkling of star. Actually, they are remain in their same position. But we are walking, so we feel that, or we observe they that they also move with us. Actually, their actual position, it is different, but from which angle we seen it, that is the difference. So that the surface of that earth, it depend on the surface of that earth. So that time the refractive index is increases, and it start traveling towards the rare medium to denser medium. The apparent position of the star keep changing a bit. This is because of the motion of the atmospheric air and changing air density and temperature. Because of this, the refractive index of air keeps changing continuously. Because of this change, the position and brightness of the star keep changing continuously, and star appears to be twinkling. We do not see twinkling of planets. This is because planets are much closer to us as compared to the star. Thus, therefore, do not appear as a point source but appear as a collection of point source. Because of changes in atmospheric refractive index, the position as well as the brightness of individual point source change, but the average position and total average brightness remains unchanged and planet do not twinkle. By sunrise, we mean the appearance of the sun above the horizon, but when the sun is somewhat below the horizon, its light rays are able to reach us along a curved path due to the refraction through Earth's atmosphere as shown in a figure 6.7. Thus, we see the sun even before it's emerged above the horizon. The same thing happened at the time of sunset, and we keep seeing the sun for a short while even after it goes below the horizon. It is clear to all of you.
Yes, sir.
Now,
Yes,
the
sir.
important part of the chapter is dispersion of light. You have a plastic scale with you. In your compass, you have a scale, no?
Sir.
The
Yes,
small
sir.
one, plastic one. Hold in your hand and keep in front of your eye towards the light. And you can see a different colors in that. Correct, no?
Yes, sir.
So how many color you can see?
Rainbow color.
Rainbow colors.
So same thing is known as the dispersion of light. Hold the plastic scale in your compass in front of your eyes and see through it while turning it slowly. You will see light rays divided into different colors. These colors appear in the following order: violet, indigo, blue, green, yellow, orange, and red. You know that light is the electromagnetic radiation. Wavelength is an important property of radiation. The wavelength of radiation to which our eye are sensitive is between 400 and 700 nm. In this interval, radiation of different wavelength appears to have a different color mentioned above. The red light has maximum wavelength that is close to 700 nm, while violet light has a smallest wavelength close to 400 nm. Remember that 1 nm equals to a 10 raised to minus 9 meter, that is n. N means nanometer. Huh? This
Yes, sir.
dispersion of light, it is given with the glass prism. Here you can see in the sunlight the different colors R, O, Y, G, V, I, V. That is the 7 colors. The process of separation of light into component colors while passing through a medium is called the dispersion of light. This you have to remember. Process of separation of light into component color while passing through a medium is called the dispersion of light. The definition of dispersion of light, and this is the diagram here to draw. The first person was the Isaac Newton. He used a glass slab to obtain some spectrum when the light is incident on the prism, and he see the different colors which went through the different angles, and all about the 7 colors. Now partially and total internal reflection. When light enters a rare medium from a denser medium, its get partially reflected. That is the part of the light and get reflected and comes back into denser medium as per law of reflection. This is called partial reflection. The rest of the light get reflected and goes into the rare medium. A light is going from denser to rare medium. It went away from the normal. The angle of the incident I is smaller than the angle of refraction R. This is shown on the left side of the figure. Here you can see. Here the angle of incident is not equals to angle of refraction. Is the internal reflection over there. So as we increase I, R will also increase according to Snell's law of the refractive index is a constant. For partially value of I, the value of R becomes equals to 90. The value of I is called the critical angle. For angle of incident large, the critical angle, the angle of reflection larger than the 90 degree. Such rays return to the denser medium as shown towards the right in figure 6.9. Thus all the light get reflected back into denser medium. This is called the total internal reflection. We can determine the value of the critical angle and as follows. We have to use this formula. 1 and 2 equals to sine I upon sine I equals to critical angle, R equals to 90. Okay. Now, rainbow production. Rainbow is a beautiful natural phenomena. It is combined effect of number of natural process. It is combined effect of dispersion, refraction, and total internal reflection of light. It can be seen mainly after a rainfall. A small droplet of water acts as a small prism. When light ray from the sun enters this droplet, it gets refracted and dispersed. Then there is an internal reflection as shown in a figure. Then after that, once again the light gets refracted while coming out of the droplet. All these three processes together produce the rainbow. These three processes together reproduce the rainbow. Which one? Dispersion, refraction, and total internal reflection of light. In this absolute refractive index of water is 1.36. What is the velocity of light in water? So velocity of light in vacuum we use as a 3 into 10 raised to 8 meter per second. That is your V1, and V2 you have to find out the velocity of light in water. So N equals to V1 upon V2. Then we do the cross multiple and division, and we get your final answer. Same thing in second sum, and you have to find out in that V1 and V2 is given. So all about we completed our chapter number 6. Correct? Any doubt?
No, sir.
So in the group today I am sending paper of chapter number 5 and chapter number 6. Where you have to solve. It is clear?
Yes, sir.
After 5
Yes,
minutes,
sir.
then we start with the new chapter, chapter number 7.
Okay, sir.
So take a break of 5 minutes.